auto scaling. Scaling is one of the first reasons organizations move to Kubernetes. So, you know, we'll discuss about the problems that come up when you try to scale container-based applications manually, and also we'll see how exactly Kubernetes handles each one. So let us make sure we are clear on two types of scaling. So what are the two types of scaling? One is horizontal scaling. We usually call it as scale out. And number two, vertical scaling. And we call this scale up. So these are the two terms. So what is horizontal scaling? So horizontal scaling means running multiple copies of your container, right? It may be on a single node or multiple nodes. So each copy handles some portion of your application traffic. You know that. So this is also called as scaling out or scale out. So this is what Kubernetes is built to do exactly. So what is horizontal scaling? So it means running multiple copies of your application or container. Okay, it may be on a single or multiple nodes. Now, what is vertical scaling? So vertical scaling means giving the container that you have created more CPU or memory. So making the container itself more powerful. So this is also called as scaling up or scale up. So it has hard limits because you can only add so many resources to a single machine. So Kubernetes primarily focuses on horizontal scaling, so which is the right approach for containerized workloads. So vertical scaling, what does it mean? Adding more power, more CPU or memory to a single container. So this is vertical scaling or scaling up. So vertically, you're giving more power to your container itself, right? So basically, Kubernetes primarily focuses on horizontal scaling because it is a right approach for containerized workflows. So Kubernetes manages how many copies are running based on the actual load, right? So that is horizontal and versus vertical scaling in Kubernetes. What are the scaling problems without Kubernetes? So mostly, human intervention is required. By the time someone sees high CPU usage and the scale up, the real users of your application have already experienced the slowness for several minutes. By the time you observe it and scale up the CPU and or memory, anything. So this is like a slow human reaction. The user, the damage is already done. Users all have already experienced slowness. But how Kubernetes handles it? There is a component called HPA in Kubernetes. HPA. What is it? Horizontal pod autoscaler. So the horizontal pod autoscaler watches, it monitors and collects the CPU and memory every 15 seconds, the real-time data. So it scales replicas, either bringing up or down without any human involvement. So it is like 15 seconds. It watches every 15 seconds. Which one? This component, which is called horizontal pod autoscaler. So what it does basically, like automatically, based on the collected uh, metrics of CPU or memory, what it does, it scales replica up or down. So on what basis or with what parameters, we'll see that in upcoming lectures. So guys, remember, like we are discussing the overview. So whatever we are discussing right now in this lecture, we are trying to understand the significance and what kind of problems and what advantages, uh, what kind of problems Kubernetes solves, and what are the advantages and how to overcome the uh, problems that we faced in the traditional application servers and monolithic applications, and also Docker. So whatever we are discussing about the Kubernetes, it is just an overview here, because these are the initial and foundational classes. So let us say HPA, what kind of parameters are used and how to implement this part. We'll see everything in detail in the upcoming lectures, right? So what I was saying is, the HPA watches CPU and memory every 15 seconds, and it scales replicas, which are the copies of your application server or container, up or down without any human involvement. So that is the important thing. So everything happens automatically.